Two fishing boats leave Fremantle Harbour at the same time. Fishing boat A travels on a bearing of 247 degrees and fishing boat B travels at 16.2 kilometers per hour on a bearing of 300 degrees. After 3 hours, boat B is on a bearing of 025 degrees from boat A. Calculate the speed at which boat A is travelling. This is quite a difficult question. It's going to be a difficult diagram to draw, and it may well be that we have to draw a rough diagram and then later on we'll draw a better diagram. Now we're talking about 3 hours, and this is 16.2 kilometers per hour. So how far will it have travelled? 16.2 times 3. That's almost certainly going to be part of what we need to do, and there's probably a mark for it. So let's get that done. So 16.2 times 3, that's going to be 48.6 kilometers from its start. Okay, so A travels on a bearing of 247 and B travels on a bearing of 300. So let's start with a north line just here. Now we know 270 is west, so 247 is going to be a bit below that, so that's boat A. Now we've no idea how far that's going to go, so I'm just going to draw a big line. Then B is on a bearing of 300, which is going to be in this sort of direction. And we know that that is 48.6 kilometers. Now that was on a bearing of 300. Well, first of all, this one here is on a bearing of 247, and then this one was on a bearing of 300. All the way around is 360, so that tells me this angle here is 60 degrees. That might come in handy. Now boat B is on a bearing of 025 from boat A, so if we position A about here, pop a north line just on A. In fact, let's try and do that a bit better than that. So pop my north line on A like this, and then we can say that this little angle in here is 25 degrees. Let's just make it a bit clearer that it's that angle I'm referring to there. So that one just in there is 25 degrees. Okay, so this is where they started from. So what I really want is this distance along here. So that's where boat B is. Let's call this S for start point, shall we? We could have used F for Fremantle or H for harbour. And if I can work out this distance here, all I need to do is divide it by 3, and I've got the speed. Now, what do we know here that could help? So, I can work out this angle just in here, because that's 300 and that's 247. So if we just do 300 take away 247, that gives us 53. We know this is 60. If I pop a north line here at B, that's 60. Co-interior angles add to 180, so this one would be 120. This one's 25. So this one, on the same basis, they must add to 180, must be 155. So that gives me this angle here. It's just going to be 360, take away 155, take away 120. So that gives me 85 degrees in here. And this angle here, 180 in a triangle, so if we do 180, take away 85, take away 53, is 42 degrees. Now, let's do some labeling that we're going to use for solving our problem. So I'm going to call this A because it's what I'm trying to find. This is then angle A. If I call this B, this is angle B. And without thinking too much, we can use the sine rule. So A over sine A is equal to B over sine B. So that's x over sine 85 is equal to 48.6 divided by sine 42. Let's use an e-activity for that. So I'll go into e-activities and I'm wanting to use the sine rule. And I'm trying to find little a. Big A is 85. Little b is 48.6. Big B is 42. And solve, and we've got 72.36, or we're going to do some more calculation with that, so 72.3551, and so on. And in fact, there's the number. I'm just going to copy it. And what did we say? That's a distance that it's travelled in 3 hours. So we just divide by 3 to find the speed. So go to main, we can paste that value, divide it by 3, and that gives us 24.1 kilometers. 24.1 kilometers per hour.